Okay, now let's look at combinations of lenses. This is just simply where I have two or more lenses along an optical axis and the light is traveling through both of the lenses. We can get a variety of images that are formed. Obviously, this has lots of applications for different instruments, microscopes, telescopes, and what have you. Um, but in a two-lens system, the image of the first lens becomes the object for the second. And once you realize this, the problems are basically the same as what we've been doing all along. We'll basically just treat these problems in two separate steps, where we'll find the image distance for the first lens, and then that image will become the object for the second lens, and then we'll find the image distance for the second lens, and then we can also calculate the magnification. Let's just jump right in and do an example. So consider this arrangement of lenses. I want to know the position and the magnification of the final image. So my first thing to do is to find what is the image distance for the first lens. I'm going to call this P1, and I have F1, and now I want to know what is Q1. Well, Q1 from our lens equation is 1 over F1 minus 1 over P1, the inverse of that. That's equal to 1 over 10 minus 1 over 30, negative 1 of that. Let's see, this is the same as 3 over 30. So this would be 2 over 30 or 1 over 15. So this would equal to 15 centimeters. Now because this is positive, that means that my image is going to be right about here at 15 centimeters. So my image Q1 is equal to 15. Right? I can also find the magnification of this image. I'm going to call this M1. It's just the magnification of the first lens. It's negative Q1 over P1. That's negative 15 over 30. So it's negative 1/2. So my magnification due to the second lens, the image is going to appear smaller, half as small as the object, and it's going to be inverted. Now I want to find what is the image distance for this second lens. So now I'm going to call this distance P2. And P2 will equal 40 minus 15, or 25 centimeters. And then I can calculate Q2. So Q2 will equal 1 over F2 minus 1 over P2. That's 1 over 20 minus 1 over 25 to the negative 1. Let's see, what is this? 5 over 100 minus 4 over 100. So that's going to be 1 over 100 or 100 centimeters. The inverse of that is 100 centimeters. Right, so our new image is going to be over here somewhere at 100 centimeters from that second lens. So this distance is 100 centimeters. And then I can also calculate my magnification. M2 will equal negative Q2 over P2. That's negative 100 over 20. That's going to be negative 5. All right, so my image now is inverted. That is, it takes this, which is upside down, and it's going to flip it, and it's going to make it 5 times as big. All right, so this is roughly going to look like this. That's going to be our final image. Now, if we want to find our total magnification, I'll just take the product, M1 and M2. That's going to be negative 1/2 times negative 5 is positive 2.5. So this image should be 2.5 times the size of the original object, and it should be upright. And as we've drawn this, we see this. All right, I draw it upright here. Remember, because I got a negative magnification due to this lens, but this was inverted, so I flipped it back up again. And also see that it's bigger. 5 times this, which was half the size of this, would be 2.5 times bigger. So this image, this final image, is 2.5 times this image. All right, here's a good question. Let's see, I do want to point out one thing, however. Not sure if this comes up here, but sometimes when you get two lens systems, you can have a scenario, extend this, you can have a scenario where your lenses, say, are close together like this. And then you have an object over here, and the object of this first lens creates an image that's over here. So for example, this distance would be Q1, and this distance would be P1. Then if I wanted to find my object distance, P2, this distance would be P2. Now this is the scenario right here that I mentioned previously where this is a negative object distance. So this value for P will be negative. And when you do all your calculations, you need to make sure that you use a negative P. I'm not sure if that comes up in this quick test here. It doesn't appear to. Well, let's just do a question real quick. So let's say that I have a lens. Let me do an example for you. Let's say that this focal length, I'll call it f1, is 10 centimeters. And then I have an object that is at 20 centimeters over here. Then I can find out what is Q1. Q1 is 1 over 10, that's 1 over f, minus 1 over 20. It's 1 over P1, this is P1. The negative 1 of that, that's going to be 20 centimeters. Right? So my magnification, by the way, is going to be negative Q over P. Negative 20 over 20 is negative 1. So my image here is going to be 20 centimeters here. "20 centimeters to the right of the lens." Now let's imagine that there's a second lens. Let's say there's a lens here, and these two lenses are separated by 10 centimeters. All right. Now I want to know, where is the image? Now I have this distance, which is going to be P2. The distance from the lens to the image is going to be this 20 minus 10, or 10 centimeters. And it's negative because the object is on the opposite side of the lens. It's on the back side of the lens, as we say. Now I can calculate Q2. It's going to be 1 over F2 minus 1 over P2. And let's say that F2 of this lens, I don't know, is equal to 10 centimeters. All right, so that's going to be 1 over 10 minus 1 over negative 10 to the negative 1, so that's 2 over 10, are 5 centimeters. All right, so my new image is going to be 5 centimeters to the right of lens 2, and then M2 will be negative Q2 over P2. That's going to be 5 over negative 10, negative 5 over negative 10, or positive 1/2. And then our total magnification will be the product of M1 and M2. It's going to be negative 1 times positive 1/2, or negative 1/2. Means if I were to draw my final image over here, my final image would be here, and it would be 1/2 the size of the original object, and inverted, because I find my magnification is equal to negative 1/2. You see some of those in the homework. You'll also find some that use diverging lenses as well. So make sure that you're able to use the diverging lenses as well. They're exactly the same, except the diverging lenses, you use a negative focal length. Although, excuse me, let me correct that. There are no combination lenses with diverging lenses.